Welcome back to another episode of Dave Does Math from Home. This is part 2 of our video series on linear functions and slope. Part 1 I tried to talk really fast in part 1 because there's a lot of information I tried to pack in there. So if you haven't seen part 1, watch part 1. Part 1 we talked about how slopes look like change in y over change in x, which usually ends up looking like y2 minus y1 over x2 minus x1. And then we did a couple slope calculations between a couple points. The main thing that I want to cover in this video is how to create equations of lines. I said that we were going to talk about slope and then come back to linear equations. This is us coming back to linear functions. So let's start again with the slope calculation. Let's say we have 2 points. We'll go with -1, 3, and let's say I do 2, let's go to -3. That one should be fine. Okay, so we have, our 2 points. What's different about this problem is I don't just want the slope between these 2 points. What I want is the equation of the line between these 2 points. And so we're going to start with the slope. The slope is going to be -3 minus 3 divided by 2 minus -1, which is -6 over 3, which is -2. I have a slope here of -2. So now we need to go from having the slope to actually finding the equation of the line. And for that, I'm going to introduce something called point slope form. Because the secret is, I shouldn't call this a secret, there's nothing secret about this. The important thing is, if you want the equation of a line, there's 2 pieces of information you need. All you ever need to get a line is a point and a slope. And in this problem, we're extra lucky. We have 2 points and a slope. So we actually get to choose which point we want to use. And it doesn't matter. It'll give you the same line either way. So point slope form is named because all you need is a point and a slope, and it looks like this. Y minus y1 equals m times x minus x1. If this looks like it came out of nowhere, then I would encourage you to look more closely at the slope formula. This thing is almost exactly the same as this thing. If you treat this like it's an equation, let me do this in a different color. If you treat this like it's an equation and divide both sides by x minus x1, what you have is this cancels and just leaves you with m on the right. So m equals y minus y1 over x minus x1, which is basically what we have here. We're just using y and an x instead of a y2 and an x2. So functionally, this is exactly the same as the slope calculation. But here's what's different about this guy. y1 is part of a point. x1 is part of a point. M is the slope. These are what give it its name, point slope form. These guys are different. The y and the x, these are not from points. These are variables. And they stay x and y. When you're using when you're using this form to create the equation of a line, x1 and y1 are going to get replaced by values. For these values, if you like. Again, it doesn't matter. x1 and y1 are going to get replaced by values. M is going to get replaced by a value. X and y stay x and y. These are variables. They're letters. They can be anything they want to be. And to represent that, we leave them as letters. We're not going to replace those with values. So let's see what this looks like. This one is a variable, stays a variable. That's going to be y. y1, we said, let's use this one. When we did our slope calculation, this was x1, y1, this was x2, y2. So let's keep this as y1 and say that this is going to be y minus 3 equals m is -2 times x stays a variable, still x. x1 is going to be -1, so minus -1. One of the most common mistakes I see students make on these problems is that they try to replace x and y with things. But one of the things to keep in mind is at the end of this, we want to get the equation of a line, which means it needs to have an x variable and a y variable in it. If your equation of a line looks like nothing but numbers in an equation that's just true, you don't have a line, you just have a weird equation with no variables in it. You need these variables for it to be a line. So, if a homework question asks you for the equation of a line in point-slope form, you're already finished. It's there. You're done. This is the line in point-slope form. Most of the questions will ask you to express the line in slope-intercept form, which is what we started with at the start of the other video, y equals mx plus b. And we can transform this into that very easily. We just need to distribute this -2. So we have y minus 3 equals -2x. Let's see, this is going to be +1 times -2 stays -2. And then we add 3 to both sides. And we get y equals -2x plus 1. Just like in the last section, 8.1, where we had a really easy opportunity to check our work and check our answers, we have that here as well. We used this point to create our line. This point should be on our line. So if we plug these values into x and y, we should get an equation that's true, and we can check that very easily. If y is -3, does that equal -2 times 2 plus 1? And I think we can pretty easily see that it does equal that. -3, this is -4 plus 1 is -3. So we have a good way to check our answer, and we have the equation of our line in slope-intercept form. I'm going to do one more of these, start to finish, with less pontificating along the way. I don't have another example prepared, so I'm just going to make up numbers for this one. Let's say we have the 2 points. Let's say the points we're working with are 7, -2, and -1. Let's go with 10. 10 seems fine. Okay, so I have these 2 points. We could make a little graph if we wanted to. 7, -2 is over here. -1, 10 is up here. So we're expecting our slope to be negative, probably about 1-ish. We're expecting our intercept to be a little less than 10. Sketching out a little mini graph like this might help you make sure that your answers make sense. when you're doing this on tests and quizzes. So we need to start with a slope, or I should say, what we need ultimately is a slope and a point. We have 2 points, so that's already taken care of. We're fine on points. We got these two. We need the slope. So we can find the slope by doing 10 minus -2 over -1 minus 7. So this is going to be 12 over -8, which is -3/2. So it's going down. It's a little steeper than 45 degrees downwards. This is fine. Okay, so we have our slope. To get our line, we're going to use point slope form. My recommendation is that you write out the generic point slope form every time. You obviously don't have to, and I can't enforce you doing it. I think it's a really good idea for you to write this out every time, just so that it's easier to remember and it becomes easier to work with. I'll use this point. That seems like a fine point to work with. Y minus -2 equals -3/2 times x minus 7. I'm going to get some fractions involved here, looks like it. There's no avoiding that. That's all right. We'll deal with fractions. So I'm going to distribute some stuff. This will become y plus 2 equals -3/2 x. This will become plus 21/2 when you multiply 3/2 by 7. I hope you're all pretty brushed up on your fraction arithmetic, because a lot of these problems are going to involve fraction arithmetic. For example, when we subtract 2 from each side of this so that we can isolate y and get this in slope-intercept form, I'm going to subtract 2 from this side and subtract 4/2 from this side, because I need a common denominator to subtract those things. So I'm going to end up with y equals -3/2 x plus 17/2. And now there's 2 quick checks we can do to make sure that this makes sense. We can plug in our other point and make sure it works. Does 10 equal -3/2 of -1 plus 17/2? This is +3/2 plus 17/2 is 20/2. That's 10. So that works out. We have the right equation. The other quick check we can do is the visual one. We were expecting something to have a slope that was negative, and we have that. And we were expecting the intercept to be a little bit below 10. And this is 8.5. So we have that as well. So this is the slope-intercept form. This is point slope form, if a question asks you for that. And that is everything that I have to say about linear functions and slope. Try the homework, be very thorough, find the hard ones, ask me questions in class. I will see you then.